Hello again. This is the second video from the Erosion student handout, beginning with part B. And let's dive right in. The phenomenon. One result of coal mining, and mining for other minerals as well, is acid mine drainage. Acidic water can flow from the mining site. How? Well, mining often exposes rocks which contain the sulfur-bearing mineral pyrite. Pyrite has sulfur in it. Well, this mineral reacts with air and water to form sulfuric acid. When it rains, the diluted acid gets into rivers and streams, turning them shades of yellow and orange. Ugh. And that can seep into underground sources of water as well. Now, at this point, what do you wonder about this phenomenon? Be curious. You can draw on the first part, A, but also just what I've read. What questions can you ask that might lead to understanding this topic better? Pause the video here and come up with several questions. Now, let's put you to work. Here's your engineering challenge. A company would like to build a hotel in the area located below a mountaintop removal coal mine in Tennessee. The hotel will bring thousands of visitors to the area, as well as hundreds of potential new jobs for its residents. As the hotel's project manager, it is your job to assess or find out what effects the mine may have to the area surrounding it. Create a plan to minimize the negative effects of the mine, and describe how to evaluate the safety of the hotel's swimming lake, which you can spot down there at the bottom. Sorry the picture is not very clear, but that's the best we found. Want to have a swimming lake right next to the hotel site just off the river. Notice the valley fill that came in earlier. And that's where the mountain used to be, but it's been taken down to this level that's kind of brownish now. That much mountain is gone. Let's move on. In the mountaintop removal mining process, several things happen, and you can click on that link, The Land of Mountaintop Removal, to see a video of this mountaintop removal in action. First of all, number one, comes the cutting. All the trees, plants, and topsoil are removed from the mountaintop. Number two, blasting. Bedrock is blasted away to uncover coal below the surface. 3. Digging. Heavy machines are used to remove coal, rocks, and dirt. Number 4. Dumping. Leftover rock and small pieces of rock known as sediment are dumped into nearby valleys and streams, creating what is known as valley fills. Look back up at the picture on the other page for valley fills. All that came out of the mine. This is rock that is not normally found on the surface and may contain sulfur. Number 5, processing. Coal must be chemically treated before it is shipped to power plants for burning. This processing creates coal slurry, or a kind of sludge, a mix of water, coal dust, and clay containing toxic heavy metals such as mercury, lead, and chromium. Not good. Number 6, reclaiming. When coal companies are finished, it may take hundreds of years for a forest to reestablish on the mine site. So let's look at the graphic that shows effects of sediments found in valley fill. On the left, pollution. The sediment from valley fill pollutes waterways and allows toxic heavy metals such as cadmium, selenium, and arsenic, that can kill a person, to leak into local drinking water. in the middle. Aquatic habitat destruction. The sediment from valley fill makes water less clear, blocking sunlight. The decreased light will slow the growth of aquatic plants, which provide a habitat for many animals, including young fish. Thirdly, flooding. The sediment from valley fill can move to streams, lakes, and rivers, making them overflow. This can cause floodings in the nearby communities. Part B, draw. Using the information on pages 3 and 4, we've just read those, draw a model to explain why the hotel company would be worried about mountaintop mining occurring above the lake where they plan to have a swimming lake. Use your own paper, preferably a blank sheet if you have one, to draw your model. Again, using information from these pages, draw a model to explain why the hotel company would be worried about mountaintop mining occurring above the lake where they plan to have a swimming lake. Pause the video if you need to. I'm going to go on meanwhile. Part B, explain. Mechanical weathering. Mechanical weathering is the process of breaking down rocks and transporting the sediments by different mechanisms. What evidence is there of mechanical weathering in the scenario that we've been setting up here? What evidence is there of mechanical weathering, and how could this explain why the hotel company is worried about their swimming lake below the mountain? Be sure to use the information in this document and even linked websites as evidence to support your answer. Again, pause the video so you can do this step. Part B, I call it solve. Now, back in your role as hotel's project manager, it is your job to create a plan to minimize the negative effects of the mine and describe how to evaluate the safety of the hotel's swimming lake. Below are the criteria and constraints for the project and the process you will use to create your plan. Now, let me be clear. Criteria is what is required. Constraints are like limitations that hold you back from just doing anything and everything. The criteria, this is what will help you judge success. Develop a plan to protect the structures around the mine by targeting water erosion. Then determine if the lake below the hotel will be safe for swimming. Constraints. Stay within the budget of $1 million. You have $1 million, but no more. And only the materials in the list above are available for this project. Sorry, it's a list coming up below, not above. Apologize for that. Steps to follow. Number 1, choose materials. Number 2, show evidence of erosion prevention. Number 3, evidence of lake protection. Number 4, your budget. And number 5, evaluation of your project. Let's look at those materials. Again, referenced right here, only the materials in the list below, are available for this project. Materials table. First material is an erosion control mat. This costs $500,000 or $500,000. The advantage is that the mats are embedded with grass seed. As the mat decomposes, the established grass that's grown up, the established grass roots, help to strengthen the mountainside. But the disadvantage, mats do not really work well in wind, and they can be washed out. Silt fence. Now, you've probably seen these at construction sites like this one, that black sort of plastic tarp there. Cost for that is $400,000. It's low cost and easy to remove, but the disadvantage is that if not installed correctly, the fence can rapidly release up to 50 tons of sediment that had been holding back. Storm drainage. This costs $500,000 at $500,000. The advantage, it allows a place for water to flow. This reduces the amount of water in the soil. But the disadvantage, the debris from the runoff water can easily clog storm drains and render them useless or make them useless. Well, there's spraying chemicals on the soil. That costs $400,000. And this helps prevent dust. It protects mining worksite and neighboring air quality. But the disadvantage, it may inhibit or cut back or prevent plant growth, as well as reduce the ability for the soil to hold water. Inhibiting plant growth, reducing the ability for the soil to hold water. All right, trees, $300,000. Tree roots will help to hold the soil in place and strengthen the mountainside. Disadvantage? Tree roots take time to develop and add weight to the mountainside. This extra weight may result in a landslide. That's it. Those are your materials. An erosion control mat, a silt fence, storm drainage, spraying chemicals on the soil, and trees. Your budget, $1 million or less. So choose your materials and circle your choice or choices below. Make sure the total cost is at $1 million or less. Step 2, using the information in the table as evidence. How will the material you chose prevent water erosion? Kind of need to explain that. What do you think? Using the information in the table as evidence, how will the materials you chose prevent water erosion? Step 3, using the information in the table as evidence, how will the materials you chose protect the lake below the mine? You want to protect that lake, keep it nice for swimming. Step 4, what is the total cost of your plan? Did you stay within the budget? Show it, prove it right here. And step 5, what could you do to provide evidence that your plan was effective? Obviously, this is a virtual environment, so you're just pretending to have done it. But if you had, what evidence might there be to show that your plan was effective? All right, here's the last section. Part D, review and revisit. We're repeating the phenomenon, so if this sounds familiar, that's okay. One result of coal mining and mining for other minerals is acid mine drainage. Acidic water can flow from the mining site. How? Mining often exposes rocks which contain the sulfur-bearing mineral pyrite. This mineral reacts with air and water to form sulfuric acid. It can get up into the atmosphere, and then when it rains, the diluted acid is kind of watered down, but it still gets into rivers and streams and turns them shades of yellow and orange, and can also seep into underground sources of water. So we have this question. Based on the original phenomenon, which I've just read, what other harmful effects could building a hotel in the area located below a mountaintop removal coal mine in Tennessee have on the visitors and the staff at the hotel? What other harmful effects could building a hotel in that area below a mine have on the visitors and the staff at the hotel? And finally, using evidence from information obtained throughout this task, could these effects be prevented? If so, how? If not, why not? That's the end of this second video explaining the erosion student handout. Rewind as much as you need to, and good luck.